All right, folks, welcome back to our second video for the area of trapezoids, rhombuses, and kites. And today we're going to deal with kites and rhombuses because the formulas for the area are the same. So make sure you did see the previous video about trapezoids because that's going to be helpful. We will be dealing with trigonometry again. All right, so here's our note. Rhombuses and kites. We got to remember what these things are. Okay, so a couple things we got to know about rhombuses. Rhombuses have four congruent sides. They are parallelograms, four congruent sides. So we got to know parallelograms. So a bunch of things happen, and the sides are congruent. And the other thing about rhombuses is that the diagonals, not only do they bisect each other, click, clack, click, clack, click, and click, they are also perpendicular. Okay, so the bisectors are, the diagonals, are perpendicular and they bisect each other. Now with a kite, what we have to remember, of course, we have two pairs of congruent sides, clearly not a parallelogram, but the diagonals do something else that are kind of cool. Now they don't necessarily bisect each other, but we have some interesting things. They do bisect at 90-degree angles, and for the short diagonal, it is bisected. Okay, so the short diagonal is bisected. So that's kind of helpful to know about a kite. And we can tell that from triangle congruence and all sorts of stuff. So what about the area of this? Now, all area things can be found by adding up the areas of the triangles. So you can easily add up the area of the four triangles in a rhombus, and you can easily add up the four areas of the triangles in the kite, or you could use this neat shortcut. The area of a rhombus or a kite is half the product of the diagonals. So multiply the diagonals, divide by 2, blam, blam, area. Special warning. Notice how it happens in a kite and a rhombus. The diagonals are perpendicular, which brings us to right triangles again. So just like we used with the trapezoids, right triangles make a comeback. So we got to look for special right triangles with 30, 60, 90s. We got to look at Pythagoras and his Pythagorean theorem. Keep your eye out for triples. And we got to remember trigonometry with SOHCAHTOA. Okay, so all this stuff comes in when we deal with area of kites and rhombuses. So we'll keep that in mind as we move along to examples. Yes. So here's our first example. What is the area of kite KLMN? Well, how do we find the area of a kite? So you remember how we find the area of the kite? It's 1/2 the product of the diagonals. So if only we knew the diagonals, we'd be fine. So we look at, let's take LN, for example. That is a diagonal. And do remember that they are perpendicular. So we do have a diagonal from L to N. What is the length of the diagonal, though? It's 3 and 3. 3 is not the length of the diagonal. It's 6. So the length of the first diagonal is actually 6 meters. And now what's going to be the length of the diagonal KM? Okay, so all the way from K to M, well, it's 2 meters from K to the intersection and 5 meters from the intersection to M. 2 and 5, of course, is 7. And so we will be multiplying 6 meters times 7 meters, and we'll be taking half of that. So, a couple of things that you can consider. The first is, well, crazy shortcut. Well, let's use the calculator. Okay, so we're going to use the calculator. We do 6 times 7 equals 42, and then divide by 2. We can do that. We're going to be 21, because multiplying by 1/2 is the same as dividing by 2. You should know that. So 1/2 of 6 times 7. Or we can do this. Check out this little trick. We know that the area is going to be 21 square meters, right? Or 6 divided by 2 is 3. 3 times 7, 21. What? Mr. Katz, do that again. No, you do it again. Rewind. So we know that the area is going to be 21 square meters. Simple as that. Simple as pie. The area is half of the product of the diagonals. Can it be that simple all the time? Well, let's find out. What's the area of a kite with diagonals that are 12 inches and 9 inches long? Did I seriously just give you this? Yes, I did. So you got to be careful, man. Area of a kite beep, 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 is equal to 1/2 the product of the diagonals. So seriously, multiply 12 times 9, divide by 2. Perfect. Or mental math, half of 12 is 6. 6 times 9 is 54. 54 square inches is our result. Or again, we could plug it in, right? So 1/2 of 12 times 9. And you can do the same thing. Well, do 12 times 9 equals, and then divide by 2 equals 54. No matter what you're going to eat, it's 54. Okay, so 54 square inches, that would be the area of our diagonal. Seriously, is this easy, Mr. Katz? Seriously, is this easy? But you got to be careful, right? Because we have to look at diagonals for their entirety. And we have to remember, brown, trig. No! Here's a real life example, which is never used it. But anyway, the high occupancy vehicle lane, that's what the HOV stands for if you ever see that on the road, high occupancy vehicle, which means you have more than you driving in the car, is marked by a series of diamonds or rhombuses painted on the pavement. What's the area of the HOV lane diamond shown in the picture? So there's the diamond in the road, right? But when you look at the diamond, it looks like this, and I zoom it out, and it looks like this. So what is happening? We have a diamond going on, and with the rhombus, this is something interesting. With the rhombus, we have a right triangle. Boop, boop. So we have 6.5 feet here, it's a big diamond, and 2.5 feet there, that's a diamond. And remember how we find the area of a rhombus. The area of the rhombus is, again, 1/2 times diagonal 1 times diagonal 2. Okay, so we have to look for the length of this diagonal and the length of this diagonal. Once we find them, we're done. The problem is we don't know the length of these diagonals, right? Because, well, I mean, we know from the length of the side diagonal, 2.5 feet here, it's going to be 2.5 feet there. Right, so we can say that, well, this is also 2.5 feet, so we know one of the diagonals is going to be 5 feet. We do know that, but we don't know the other one. How are we going to find the other diagonal? Hopefully you know. If we found this leg of the right triangle, we would be good to go. Okay, so if we found this leg of the right triangle, we would be good to go. So, how do we find that leg of the right triangle? Our good friend Pythagoras. Okay, so we're going to find this right triangle, this leg with our friend Pythagoras. Pythagoras says 2.5 squared plus, we don't know, squared will equal 6.5 squared. That's what Pythagoras says. Okay, so our Pythagorean theorem comes into play. So, let's do some calculator work, right? 2.5 squared is 6.25. So 6.25 plus, we don't know, squared is equal to 6.5 squared. So let's do 6.5 squared, and that gives us 42.25. So now we're going to do is solve for the variable. We're going to subtract 6.25 from both sides. So we subtract 6.25 from both sides. We end up with, can it be this easy? We end up with 36, okay? So the square of the long leg is equal to 36. How then do we solve? We take the square root. Thank you, Pythagoras. So what we're looking for is actually 6 feet. Okay, so what we're looking for is 6 feet. So we go back to our diagram and make sure that we are approaching everything correctly. Well, thanks to Pythagoras, we know the long leg is 6 feet. So is our other diagonal 6 feet? No, be careful. The other half of the diagonal is 6 feet, so all the way across is going to be 12 feet. So we must be super duper careful. When we're talking about half the two diagonals, the product, it'll be 5 feet, we know from the short leg, boom, boom, 5 feet. And it'll be 12 feet from the long leg, 6, 6, 12 feet. So we'll multiply those and then take half of that. So we can do calculator work, we can do mental math even, because half of 12 is 6. 6 times 5 is 30. Okay, so we know the result is going to be 30 square feet, or we can use the calculator. 5 times 12 equals 60, divide by 2, and then we find out it's 30 units. So we know what we're going to get is 30 square units, or 30 square feet in this case. Okay, and that's how we use trigonometry to get us to the area of a rhombus. Let's do another example, because that was fun, I hope. All right, anyway, let's read. A rhombus has sides 10 centimeters long. Is that enough information? I don't know. Remember what a rhombus is, ladies and gentlemen. Rhombus has 4 congruent sides. So that's all we need to know, right? A rhombus has sides 10 centimeters long. Boy, do we have some information to use. 10, 10, 10, 10. So now the question is, if the longer diagonal is 16 centimeters, bloop, 16 all the way across, what is the area of the rhombus? Now remember how we find area. We find the area of the rhombus by calculating half of the product of the diagonals. Okay, so half of the, we know one of them is 16. We already know that. So the question is, can we find the other one? Well, let's look for the other diagonal. Boop. Now, what do we know of the other diagonal? What do we know about anything, really? Look at what's happening here. We have a bunch of right triangles. So if we could look at just one right triangle, we could find the information we need. So let's just zoom in to one of the right triangles, shall we? When we zoom in to one of the right triangles, hopefully you see is this one down here. Boop, boop, boop. Let me draw an arrow so you know which one we're talking about. When we zoom into one of the right triangles, we have a couple of lengths, right? So we have a 10 here. What then is the long leg here? The whole diagonal is 16. So hopefully you know that the long leg we found is 8. Now, I could ask you to hit pause here and you find the other leg by using the Pythagorean theorem. Okay, so you would do 10 squared, hypotenuse square, the square of the hypotenuse is equal to the sum of the squares of the other legs. And do your math that way. Now you can continue from there. I'm not going to do that. What I'm going to do is remind you of a shortcut. I'm going to remind you that we have a 3, 4, 5 Pythagorean triple on our hands. And you're going to say, wait, what? Yeah, dudes, check it out. Did you know that 10 is 5 times 2? You should know. And did you know that 8 is 4 times 2? You do now. So what does that mean the short leg is? If we have a 5 hypotenuse, a 4 leg, that means we have another leg 3. We have a 3, 4, 5 right triangle in our hands. So the short leg is 3 times 2. So we know the short leg, 3 times 2, or 6. Okay, so we know the short leg is going to be 6. So I can tell you right now, short leg x is 6. Now, does that answer anything at all? No. The question was, what's the area of the rhombus? And we know that area is 1/2 the product of the diagonals. We know that one diagonal is 16. Do we know what the other diagonal is now? Yeah, we do, because check this out. If the short leg is 6, that means the short leg is 6, that means the short leg is 6. If this short leg is 6, what's the other short leg? 6. So then we have 6 and 6. What's the other diagonal? 6 and 6 is 12. So we have 1/2 times 16 times 12. Half of 16 is 8. 8 times 12 is 96. So we have now found, or calculator work, so we have now found the area to be 96 centimeters squared. That is our area. And all sorts of the beautiful things that can come with it. And folks, that's enough for today. I hope you have learned some stuff about area of trapezoids, rhombuses, and kites. I'll see you later for some more area of polygons. Peace.